hooking that resistor. Surely that can't be good. Maybe hooking that resistor other than the chassis is a mistake. Maybe. What else could I have done that's wrong? Okay, so just using this just like this, because we're just going to look at the there we are. The resistors I put in. Not even showing up. Something didn't work out here. Something did not work out here. So where I connected this resistor, I can see the wire go to the ground. Did I make a mistake with the resistor? No. So they're showing the resistor tied to the something a little bit different here with how that was done versus how this looks. So hang on a second here. What's happening? So this resistor that was soldered to the chassis here is soldered to not to the chassis. R3. Where's R3 go on the schematic here? R3. No, that's 1,000. R3. R3, I got this backwards. R3 is the 1,000. R2 neither of these are connected to ground. Whoa, what's happening? Turn it off while we figure out what is going on here. What has happened? So R3 is shown. I got this right. So there's a big solder blob on the chassis just under here, and R3 was connected to it. But here on the schematic, R3 is connected to one of the pins on the filter capacitor, and that could be the same thing. That could be a chassis pin. But off it is coming a red wire. That's usually indicative. It's going right to a screen grid. So, hey, that makes sense, doesn't it? Because R3 is involved in the screen grid circuit. R3 is involved in a screen plate. It's another fine mess here. Let's go over it again. Because something is not adding up. Let's just start right here. 2 tubes and a transformer. 2 tubes and a transformer, no question. I've got that right. Terminal here, it's got 4 posts on it, one of them not connected. This guy's got 4 posts, 1, 2, 3, 4. The first one's not connected. the resistor R3 comes from the third post in. So 1, 2, 3, third post in, coming from there. It runs R3. It runs very carefully. It runs to the one of the terminals on the capacitor. Now, one of the, yeah, that's right. That'll be this guy. Oh, wait a minute. Is that right? Ooh, don't jump. To conclusions. 0.01. This tricky stuff. It runs all over the place. I lost track of everything? No. There's the 10,000. So basically you've got a series circuit here of coming through this resistor, and then through this resistor, and onward. The three of them are basically in complete series. I should be able to see that looking in here. I should be able to see that. Okay, let's see if we can see that. Start here at the ground. It's not supposed to be grounded. Come up through here. Capacitor off of here, but then it's forced through here. Capacitor off of here, and then it's forced through there. Capacitor at every junction. So we come out of here with no capacitor. Come out of here. So this comes out. Oh, I'm sorry there. I'm just doing some terrible camera work. Here, sorry about that. So all this looks different. Have I got the right schematic for crying out loud? Let's try it again. So starting from here, we come along right on the other side of this resistor. This resistor being R3. R3 being a size other than what I put in. R3 is 1,000, so this should be 1,000 was going to ground here. How could that possibly have worked? Wow, okay, so I'm either on the verge of making a huge mistake here because my head has gone screwball, or somebody previous to me made some kind of mistake. Let's trace it back the other way. Let's start at the plate. Okay, it comes off the plate, is forced through a resistor and coil, forced through resistor coil. On the other side, this capacitor is sitting here. There's no capacitor there. Okay, let's keep going. So then the next thing it does is it rolls through 1,000. No, next thing it does, it rolls through 3,900. I've got it rolling through. I got these two backwards. What dork. Okay, so I have to switch these two around. It took a lot to get them in there. And at that point, between the two resistors, there's a 0.01 to ground. There it is. That's the 0.01 to ground between the two resistors. What's this? What is this? Where is he supposed to be? So, oh look. Okay. So yeah, you guys have all seen it. I'm seeing it now too. Up here. So that's that. Okay, that's fine. Everything's fine. Except I put the capacitors in, the resistors in backwards. What difference would that make? I mean, they're just in series here. That shouldn't kill the radio at all. 1,000. I can't imagine that. Oh. Okay, I gotta switch those two resistors in a while. Okay, here's my conclusion here on how it is the resistor I cut out was attached to the chassis here. You know, I don't think it ever was. I thought it was. What really happened was the wire tail from the original resistor, I wiggled it a little bit, it broke off. I thought it broke off from down here. Chances are it broke off from here. And this is the correct terminal to be connected to. So this resistor I've got grounded. No! So I got to take this off, attach it here. It's really a source of high voltage coming through here, reaching the plate, and then distributed out among the screen grids and plates too, I guess. So I really kind of cut off the plate supply here. And then, of course, I've got these two resistors in backwards. Is that really true? Let's just make one last check of that. R2, yeah, backwards. Okay. Son of a gun. Not enough coffee. Okay, so I've managed to sort things out here. I've got the 39 in the right spot, and I've got the 1000 over here. And of course, makes perfect sense. The 1000 is the first resistor through which all the power flows from the capacitor here on its way to plates and screens. So if you measure here the voltage drop across this resistor, you can figure out the current flow going into that circuit. It wouldn't tell you where it's going exactly, but there's probably some information somewhere you can compare the value to and then go, that's okay, and everything out there must be okay, or that's not okay, there's something to be found further in the radio. So I think that's one of the reasons for the 1000 there. Easy calculation with an ohm meter, with a voltmeter, rather. Okay, let's switch them on and see if it doesn't work this time. Going down. Here we go. Significant change to the B+, so we'll start off with the dim lights. Boy, are they ever dim. This radio is very slow. It's a slow radio. Really slow. There they come. Very hard to see, but this bulb's starting to glow just a wee bit. That's unusual. Usually you get kind of a flash on those as the tubes warm up. Okay, full power. Volume. That's reassuring. Let's tune this guy. There we are. We're back in business. So that tone you hear, I believe, is a heterodyne between the station heterodyne. Between the station we're listening to and a noise signal that's just a little, well, what was that? That was about 1000 hertz tone, about 1000 hertz away from it. Some kind of noise signal. So you have the two carriers sitting there, and the difference is what you hear, the 1000 hertz. There's no escaping it. If that's true, then tuning back and forth shouldn't change the pitch. Well, it doesn't. It's one pitch, because the two signals are fixed in place. That's my theory. It's working better. Better and better every time. There's that horrid noise there. It's right at the end of the band. Okay, so I'm going to leave this running a bit. I'm going to go get my thermal viewer I've been playing with. We're going to take another look at these resistors and see what's happening. I'll just leave it playing here. Ooh. That sounds like single sideband almost there. Okay, let's take a look here with the viewer. I'm just going to use it like this in front of the camera here. Switch on. There we go. Okay, so look. Something's pretty warm in there, and I think it might be that resistor. Let's try the blocking thing. I should not use a metal blocker. That's foolish. I need to use a plastic blocker, not my finger. It'd be the simplest thing in the world. Well, I gotta get something just a little bit useful here. Okay, it's a little oversized, but let's start with this anyway. Okay. I'm not gonna be able to tell what I'm blocking. Yeah, I can't tell with this. Okay, let's cut this out. make a blocker. There we are, professionally made blocker. So let's see, so yeah, it's definitely this resistor. Now how hot is it? It is, let me just get this in the middle here. Right there. Ooh, it's still pretty warm, eh? Come on. 50, 60, 90, 90, 90. How did it get up to 90? 90, almost 100 right in the middle. Is that for sure, that resistor? She's cooking. The trick here is you can only block the one thing you think it might be. Ah, it's seeing right through the plastic. Infrared's going right through the plastic. Now I see when I block that, the other resistor comes into better view. That's this one down here. Look, this is the coil one. What's it running at? 40, not nearly as bad. And what about the 1000 I put in? It's also around 40. So this guy here is really cooking up. 100. No wonder it was brown. The original one had gone brown. 100 degrees is a little high. I don't really see how I can arrange. This is not, the original one was tucked in there tight. This is a little bit looser. I've got longer leads. All this stuff is heat related. I got longer leads here. Still, it's not hot enough to melt the solder. Nowhere's near that. Nowhere's near that. Okay, anything else hot in there while we got this guy out? And we're looking around. Okay. So, oh yeah, so there's that big high wattage resistor in the back there. And, sorry, I can't look at everything at once, so I'm not... Hui, yeah, okay, so that's that resistor there, and it's heating up the area around it. 60, 80, 100, ooh, wow, that's a hot one. But look at the style of resistor. It's made with materials that can take that kind of heat. So we're going to leave them there. Anybody else? Anybody else? Thought I saw somebody else here. Nothing should be hot up here in the front end. I would expect that would be. And what we're looking at here. Some of the resistors down in here, or the tube socket itself, is starting to show heat. I think all is good. Let me put this over here where I won't damage it. Good. So, where are we at now? So we got the tone control capacitor changed. We sorted out these resistors here after a bit of monkey business. All seems well. You notice I'm not measuring the DC voltages in there. And what's left to do on this radio now? Wow, we're getting down to some tough stuff. The speaker. So I've been thinking a bit about this speaker. And it's completely free cone here. Everywhere. It's never been glued down. There's some kind of ring that should be on here holding this down. Where's the ring? I don't know. So I'm thinking about this stuff right now. Maybe there's something in the radio cabinet that will show this. I'm thinking, how can you put this in like this? If you tip it on its side, the cone is gonna fall. I'm gonna screw it in with the cone tipped. And I'm thinking about all this stuff. Thinking about it all. And that's about it, really. Setting up the push buttons. And that's about it. We're just about finished here. Excellent, excellent. Well, I hope you enjoy your day. I'm off to enjoy mine. A little bit of rain coming this afternoon, and we need it. See ya.